Today we want to look at how we can solve some questions under the topic quadratic equation, but I've grouped the questions into cases. Let us look at case 1. Case 1, we have been asked to solve the following equations. Let us look at question number 1. With question number 1, we can see that what is in the bracket has already been simplified, all right? And we equate them to what? To 0. So this is what we are going to do. We pick the first bracket, we equate it to 0, then we solve for our x. We pick the second bracket, we equate it to 0, then we solve for the other x. Now let's see how we can do it. So we have 3x plus 1 equal to 0. Now what can we do? We let the positive 1 cross the equal to sign, and we are going to have 3x equal to minus 1. Now we divide both sides by 3, and x is going to be negative 1 over 3. What do we do again? We pick our x minus 2 and equate it to 0, and x will be equal to 2. Therefore, we can say that x equal to minus 1 over 3 or 2. Alright? Now, use this approach to answer question number 2 up to number 8 and leave your answer in the comment section. We want to look at case 2 of our topic quadratic equation, where we have been asked to solve the following equation. Now let us look at question number 1. For question number 1, we are looking for x. And the first approach we are going to use is by sending our negative 9 to the right hand side of the equation. And we are going to have x squared equal to positive 9. The second step is that we get rid of our square by finding square root of both sides of the equation. And we are going to have x equal to, now, anytime you are finding a positive square root of a number, you bring plus or minus. So we have plus or minus square root of 9. So our x is going to be plus or minus 3, where we can have x equal to positive 3 or negative 3. Now, with our second approach, where we have x squared equal to x squared minus 9 equal to 0, we can use difference of two square approach, all right? Where we have this equal to 0, and we can break this as x minus 3, our x plus 3 equal to 0. We pick this, then we equate it to 0. We also pick this, we equate it to 0 to solve for our x. So we can see x minus 3 equal to 0, x will be equal to positive 3. Picking this, we have x plus 3 equal to 0. We are going to have x equal to minus 3. Therefore, x will be equal to 3 or minus 3. So, we can use any of this approach to solve question number 2 up to number 8 and leave our answer in the comment section. Thank you. We want to look at case 3 of our quadratic equation, where we have been asked to solve the following equation. Let us look at question number 1. Now, question number 1, we have been given 15x squared minus 6x equal to 0, and we are looking for x. First of all, we need to simplify this using factorization approach before we can solve for our x. Let's see how we can do that. Now, we have 15 here, we have 6 here. We look for a common number that can go into 6 and 15. Then we factorize it, and that will be what? 3. Now we have x raised to the power 1 here, x raised to the power 2. So we factor the variable with the lowest exponent out, and which is going to be what? X. So we are going to have 5x here minus 2 equal to 0. At this stage, we pick the 1 outside the bracket, then we equate it to 0, then we solve for x. So we have 3x equal to 0. Divide here by 3, divide here by 3. So x will be equal to 0, alright? We pick this also, then we equate it to 0. So we have 5x minus 2 equal to 0. So 5x equal to 2. Divide here by 5, here by 5. So x will be equal to 2 over what? 5. Therefore, we can conclude by saying that x equal to 0 or 2 over what? 5. So this is how we can solve this equation. Using the same approach, solve question number 2 up to number 7 and leave your answer in the comment section. We want to look at case 4 of our quadratic equation, where we have been asked to solve the following equations. Now let us look at question number 1. With question number 1, we want to solve for x in this equation here, and we are going to use the method of factorization to solve it. Now, how can we use that method? First of all, we use the coefficient of x squared to multiply our constant here, and this times that will give us negative 20. We look for two numbers. When we multiply, we'll get negative 20, but when we add, we'll get negative 8, and those two numbers must be factors of 20. Now, there are so many factors, but when we look at 10 and 2, all right, when we introduce negative sign to the 10 and we have negative 10 times 2, it will give us negative 20. Negative 10 plus 2 will give us negative 8. Therefore, the factor we are looking for will be negative 10 and 2. We are going to use these two factors to replace our negative 8x. Let's see how we can do it. So we have 4x squared, all right, minus 10x plus 2x minus 5 equal to 0. At this level, we group the first two and the last two and factorize. Let's see how we can do that. We have 4 here, we have 10 here. We look for a number that can go into 4 and 10 at the same time. And the number is what? 2. What again? We have x squared here, we have x. We factor the variable with the least exponent out, and which is going to be x. So x will be out. Therefore, here will be 2x minus 5. Now, when we look at this, 1 will be the common factor. So we bring 1 out, and we have 2x minus 5 equal to 0. Now, we group those outside the bracket, all right? And we are going to have 2x plus 1. Now, all the time, make sure that what is in the bracket here is the same as what is here. If you tap it that way, then it means what you are doing is correct. Now, since this and that are the same, we bring only 1. So 2x minus 5 equal to 0. We pick this, we equate it to 0, then we solve for x. So 2x plus 1 equal to 0. 2x equal to minus 1. We divide here by 2, here by 2. So x will be equal to minus 1 over 2. We also pick this, we equate it to 0 to solve for x. So we have 2x minus 5 equal to 0. 2x equal to 5. Divide here by 2, here by 2. So x will be equal to 5 over 2. Therefore, we can conclude by saying that x equal to minus 1 over 2 or 5 over 2, as we can see. So this is how we can solve this equation. Use the same approach to answer question number 2 up to number 6 and leave your answer in the comment section. Thank you.